Hello everyone. So hello student grade 9. So this session we focus on review question. So we going to solve some exercise in review question of our chapter 14. So the objective of this session, I hope you can choose all the property of similar figure and solid to solve exercise, like the ratio of area and the ratios of volume. So before going to solve some problem, I'm going to review you some questions. So the first, to write down the ratios of area of the similar figure. And next, write down the ratio of volume of the similar figure. Okay. So the answer of review is, if we let L1 and L2 are the corresponding length of the two similar figures, while the corresponding area are A1 to A2, then the ratio of A1 to A2 equal the ratios of L1 over L2 to the power 2. Okay. And for the volume, if we denote the volume of figure by solid by V1 and V2, then the ratio between V1 to V2 is equal to the ratio of L1 to L2 to the power 3. Yeah. So when we talking about the ratios of area, we take the ratios of length to the power 2. But when we talking about the ratios of volume, we take the ratios of length to the power cube. So let's consider example number 4. We have volume of the similar cylinder in the ratio 8 to 27. So this means volume V1 over V2 equal 8 over 27. Yeah. In next question, A, find the ratios of the base radius of the cylinder. Okay. And question B, given that the curved surface area of the smaller cylinder is 96 centimeter square, find the curved surface area of the larger cylinder. So this one, the smaller cylinder, it means we will take the smaller radius. Yeah, it's corresponding smaller radius. So the answer, we first denote the R1 and R2 and the corresponding radius of the two similar cylinders, while the corresponding volume are V1 and V2. Sorry, this mistake should be as not area. Then we can write down the ratio of radius to the power 3 equal the ratios of volume, that is 8 over 27, that it can be converted to 2 power 3 and 3 power 3. Then the ratios of radius R1 over R2 equal 2 over 3. That complete the question A. Yeah? The ratio of the base radius of the cylinder is 2 over 3. That is the answer. We find the ratial surface area. So ratial surface area is defined by A1 over A2 equals R1 over R2's power 2. Since the small surface area is 96 centimeters square, and we put at the numerator because the value radius of 1 is 2. Yeah? The 2 is less than 3. So the numerator be the smaller cylinder. So you take 96 on the numerator. Then this number can be converted to 2 power 3 equal 4 and 3 power 2 equal 9. Yeah? So to find A2, just take 4/9 multiply with the 96. Here's a 96. So 96 multiply 9 and divide by 4. And 96, it can be simplified by 4. So equals 20, 24, okay? 24. Then take 24 multiply 9 equal 216 centimeters square. So the area of the larger cylinder is 216 centimeters square. Okay, next go to exercise number 6. It's a status has a base of area 7.04 meter square. A similar model made a material of the same density has a base of areas 800 centimeters square. Find in turn the mass of status if the model weight is 42.5 kilogram. So it means the second status has mass 42.5 kilogram and its base area is 800 centimeters square. So this unit be different. So you have to convert meter square to centimeter square by multiply by 10,000. Okay, let's have a look at the solution. So before do it, we should denote some letter represent length, like L1, L2 represent length, and D1, D2 represent density, and M1, M2 represent mass, and V1, V2 represent volume of the two similar status. Okay. Then we got information that the status made a material of the same density. Then the D1 equal D2. Okay, D1 equal D2. But density equal mass over volume. So D1 equal mass M1 over V1. So volume V1. Okay, the same is one. So these two proportion, the proportion can be converted to M1 over M2 equals V1 over V2. So this means the ratios of mass equal the ratios of volume of the similar figure. So next, you have to find the ratios of length, because to find the ratios of mass, that equal the ratios of volume equal the ratios of length take to the power 3. So for to find the ratios of length first, that equal the square root of ratios of area. So A1 over A2, and you replace A1 by 7.04 and multiply by 10,000 because we convert it to centimeter square. Yeah. And A2 equal 800 centimeters square. Then by simplifying this number, we obtain 22 multiplied 100 over 25. Yeah. And then you to compute simplify this number equal 2 square root 22. 2 square root 22. Because 100 divided 25 equal 4. So 4 come outside radical equal 2. So 2 square root 22. So the ratios of L1 over L2 equal 2 square root 22. Okay. Then the ratios of volume equal the ratios of length power 3. Then the ratios of mass also equal to ratios of length power 3. So we just replace M2 equal 42.5 and this ratio equal to square root 22, because if we found that this ratio equal to square root 22, this means the length L2 be the length of the small status. Yeah, the length of the small status. So the small status is have mass 42.5 kilogram. Yeah. So we put a denominator. Then when we find M1, just take 2 square root 22 power 3 and multiply with 42.5. Okay, then this we got the answer is equal 35,084.31 kilogram, and it can be converted to tons by divided by 1,000, so equals 35.08431 ton. Okay, so we finished our presentation, and thank you for your paying attention, and I hope you enjoy next step.